to the lecture series on soft computing in computer science. As an introductory topic to this subject, soft computing, so what are the topics that we are going to cover in this presentation are what is meant by a problem and example for few problems, and categories of problems and the ways to solve problems, and among the computing way to solve the problems, and what are the manners of computing ways to solve a problem, and what are the computing ways in a problem solving technique, and there are two ways of computing, hard computing and soft computing, and what are the constituents of soft computing, they are neural networks, fuzzy logic and genetic algorithm. Finally, we are going to conclude this presentation with the requirements for soft computing, areas of soft computing and applications of soft computing. Let me go one by one. Problem. So in general, what is a problem? It is something you need to figure out to get what you want. Yes, of course, if you are facing any difficulty in understanding any particular context, and if you want to derive any remedial measures for a particular circumstances, or if you want to derive any solution for a particular statement, all these are stated as a problem statement or in general problems. There are, strictly speaking, whenever you come across the word problem, you may mean to say that it is a mathematical problem. But when you come to the soft computing introduction, apart from mathematical problem, we are also going to dealt with some real world problem. So as you see, finding a large number from a set of numbers might be an example for a mathematical problem, and finding a shortest path or making some decisions in some uncertain situation may be a example for a real world problem. Let me give an example. Consider the set of blocks here. So here the problem is to identify the shape of the block, whether it is circle or square or rectangle. So this is a problem. And consider another situation that you have two choices of having some snack or some fruit to eat. So one choice you can choose go for apple slices, and one choice you can go for carrot stick. So which one you wish to pick? So of course this is also treated as a problem. And another example for a problem statement, that is your objective is to, or your task is to arrange as many as possible cookies in a plate, and you are provided with two choices of cookies. One is large number cookie, that is large size cookie, and another is some smaller sized cookies. If you want to go for as many as maximum possible number of cookies, definitely you would go for choosing a small cookie. That's what you can fit more number of cookies in a plate. So these are all the few examples for problem statement. So what are those problems? Identifying the shape, choosing between apple slices and carrot stick, arranging more number of cookies in a plate. All these problems can be put together in three different categories. Those problems are termed as pattern recognition problem, decision making problem and optimization problem. So let me explain this problem one by one. What is a pattern recognition problem? So everything around us, you may view that as a pattern. A pattern can either be seen as a physical or it can be observed as a mathematical by applying some sort of algorithms. Maybe size of a particular object and texture of a particular object, or something like digit recognition or identification of speech pattern. So everything that falls under this particular category of problem. Next, decision making problem. So here you are provided with some uncertain situations. You do not know whether your choice is an ideal choice and it will lead to the target or not. And these kind of uncertain situations, you want to always choose between some what can I say, some diplomatic situations, and you need to go with one choice or one route so that you can reach the destination. So the best example as it given is in the maze game, right? So it's a puzzle game. So you have to start from one place and you have to exit from the another place, and while choosing all these situations, you need to go for with only one choice, either yes choice or no choice, right. So these set of problems are called under the category of decision making. And the third category of problem is optimization. So this optimization is there in every walk of our life, and the objective of this optimization is desire to seek perfection. That means whatever the task that you are going to carry out, your objective is to finish the task with as much minimum effort and maximum profit. So in this case, if you look at that example, a person is walking along the road, he is facing 5 different possibilities. Out of the one possibilities, if he choose, the person can reach the destination in a lesser time. So when you take this maze game, see, he also have so many situations, so many possibilities, but only one possibility is there to reach the destination. But here many choices are there, each will lead to the destination, but he has to choose one destination based on the objective criteria. So these are the 3 problem statement: pattern recognition and decision making and optimization. These are the 3 problem categories one can see in many of the contexts. Okay. Now how to solve those kind of problems? If you could see that in general any problem can be solved using pen and pencil, right. So yeah, some teacher is there, he is called as a mathematics teacher, and he is going to give some problems, and you have to understand that problem, and you have to apply the formula that is most appropriate for that problem, and using pen and paper you have to substitute the values for the problem, and then you find the solution, right. So that is the usual and the more general way to solve problem. But why this particular machine has been introduced? This machine has been introduced in order to speed up the process of problem solving. In the manual way, even though it is always ends at good results and accurate results, but it is a time consuming process. So in order to solve such kind of problems, in general one can go with the help of some machines, particularly calculators or computer like that of machines. So in a computing way, that means using some machine to solve a problem, you may encounter into 3 phases. What are those 3 phases? In general, input phase, processing phase and output phase. In input phase, you are asked to read the input pertaining to the problem situations. In the processing phase, the formula or the procedures or any strategy has been applied over the input in order to produce the output. So in the output phase, the raw output or the actual output that is come out of the problem solving procedures has been presented in a way so that it can be better understandable by the end user. So these are the 3 phases by means of which, that means computer can be used to solve a problem, and this approach is treated as the, and this way is treated as the computing way of solving the problem. In this computing way, you can go with 2 different kinds of manners, that is in terms of obtaining the result. If you are always intended to obtain a precise or exact result, then it is treated as a one manner, that is called precise manner. In another procedures, you are always expected to give some approximation results. That means you need to solve the problem in an approximate manner. So there are 2 possible manners while doing the problem solving in computing ways. In the precise way, you need to apply some hard and strict rules. That means you need to apply the formula and its associated derivations, and your problem should be changed according to the problem, according to the formula. So this kind of computing way, that is a precise manner of obtaining the result of through computing way, is completely mathematical. Whereas when you go for the approximate manner, so it is based on some soft and relaxed rules. Rather than with the application of only formula, here in this case you will always encounter some sort of real world situations, how a real world situation has been tackled and how the real world situation problem has been solved. That procedure has been taken into consideration and the problem has been solved. So overall, what I would say to you is, in the computing way of approaching the problem solving, you can derive the results either by precise manner or by approximate manner. If you apply hard and strict rules by means of some mathematical formula, definitely your problem solving procedure will end at a precise manner. Whereas if you go for solving the problem by means of applying some relaxation, some hard, some soft and some kind of relaxed rules by through some adaptability or some through flexibility in the way how the real world situation has been tackled, how the real world problem can be solved by human being. In those aspects, if you proceed in the computing way, then it is called approximate manner of solving the problem, approximate manner of obtaining the solution to the problem. Let me take a small example in order to understand the difference between precise way and approximate way, right. Let us take an example of waking up the morning. So what you have to do while you want to wake up early in the morning, you will set an alarm, right. So if you set an alarm for about 6 a.m. say for example, if you in the precise way, if you could see that immediately after the 6 a.m. has been struck in the clock, alarm sound will come. It means that immediately after this alarm has been make a sound, you will start waking up and you will start doing the all the regular activity. So in that case, when you start doing the regular activity, you are not a machine. So at the sharp time, you will not wake up and do all your regular activity. So that is what expected in the precise way. But what is in general it is happening in the real world situation, when an alarm sound comes, you wake up, switch on the alarm and put it for some more 5 minutes and then switch on the alarm and it put for some 4 minutes. So relaxedly in a leisure way you will start waking up. So that means not sharply by 6 a.m. you will start waking up, but slowly you will gradually you will wake up maybe around 6:30 or 6:15 or sometimes around 6:20 you will start waking up from the bed. So this is called an approximation way. So in general, when any one person is asking you at what time we will meet, so you will say some exact time, maybe 7 o'clock or 8 o'clock or maybe 10 o'clock. But in what the practical procedure is around 10 to 10:15 or around 10 to 10:10 or around 10:05, it is the general customized procedure of real world situation in giving up the timing procedure for meeting. So this is the way that I wish to inform you the difference between precise or exact as well as with the approximate way. So whenever you say the problem solving procedure through computing way ends in a precise result, that means it is a very prompt and exact results and it always follows the strict rules. Whereas in case of approximation way, there are some flexibilities, there are some relaxation is there in obtaining the solution for the problem. So overall picture, when you take the case of the computing techniques in problem solving, you may face two different kinds of computing. One is hard computing, another one is soft computing. In hard computing, the model obtained is called as a precise model, whereas in soft computing, the model obtained is treated as an approximate model. So in the precise model, we have plenty of categories: deterministic model, binary logic and numerical values. But whereas when you take the case of soft computing, it is always ends in approximate model. Here we have two different varieties. One is comes with approximate reasoning, another one is comes with the functional approximation or something called as randomization search. I will teach you what is this approximate reasoning and what is this functional approximation while going into the advanced topics. As of now, approximate model will face two different ways of computing. One is aimed at reasoning, another one is aimed at optimization. Right. Under the reasoning category, you have two things. One is based on the probability, another one is based on the fuzzy theory, that is probabilistic model and fuzzy set theory model. Under approximation category, you have evolutionary computation as well as neural networks. So these are all the possible ways of computing a problem through problem solving techniques. Now comes to hard computing. As I said earlier, if you want to obtain a result in a precise manner, then what you have to do? You have to apply some hard and strict rules by the way of formulas. So in general, hard computing is nothing but usage of traditional mathematical models to solve a problem, and it is always based on deterministic and precise calculations. And overall, this hard computing is an ideal way for solving the problem that should be well defined, and it needs a well defined mathematical formula for solving a problem. So what are the characteristics of the soft computing? From the presentation, you could come to know that precision and exactness is the first requirement for hard computing. That means the algorithms that you are going to use under these hard computing should be always rely on precise calculation, and it will always gives out exact algorithms. Second characteristic is well defined. So whenever you want to solve a problem using hard computing, you should always remember that the problem should be well defined. Even if the problem given to you is something clumsy or something in a not organized manner, the first duty before solving the problem is to organize the problem in such a way that it should be well defined. Each and every this kind of problem will depend on a formula. So in formula, what are the things are there? You may have x, y, z, something variables are there. So we need to understand that what is x, what is y, what is z, and how that x value has been derived from the problem statement, and how y is defined there. So everything you should identify. So it means that overall the problem should be a well defined problem. And apart from that, you need more information about the problem. Yes, of course, if they given the problem statement in a straight way as a mathematical statement or as a natural language statement, and there are certain situations you are not at all in a position to understand the problem fully. So what you need is, you need further more information about the problem, then only you can proceed with solving the problem. Next is deterministic nature. Yes, of course, the result obtained through hard computing should always be a predictable, and it should always be a repeatable one. So that it is called deterministic in nature. And another case, it is the way of hard computing is it always use yes or no logic or strictly true and false. Only the two cases are there. One in that case, that means a true or yes category, another in that case false or no category. So intermediate stages are not acceptable in hard computing approaches. Let me come to our core topic, soft computing. Why these kind of soft and relaxed rules are required in order to obtain approximate result? Because it is our human tendency always try to solve a problem by the way of something like always looking for some kind of significance. So look at this picture. What is the difference between precision and significance? Suppose you and your friend are going along the road, right? Suddenly a heavy mass stone is coming and it is trying to fall over the head of your friend. What you will do immediately? Immediately you will jerk at the situation, and you will try to safeguard your friend by pushing the friend, or you will say loudly to alert your friend. So that is the general procedures of a human tendency, that is called significance. Rather than if you could start saying that, see my friend, some 1500 kilogram of weight stone is coming and it is going to fall under our head. If it falls under our head, you imagine your situation. Like that only you want to describe at that situation. So if it is a machine, definitely it will say like that. But if it is a human, then you will always try to safeguard the person, and you will react to the situation according to the situation, not to the problems formula, right? So what is soft computing in general? Yeah, soft computing is the one that always uses human like a decision as well as natural selection to solve any complex problem, and always try to provide quick and cost effective solution. What are the characteristics of this soft computing? So tolerance for imprecision. So whenever the problem is an uncertain problem, that means you are not sure about that problem. That means you are trying to solve a problem and you are going to obtain a solution about the problem, but you are not very sure about that problem statement. You are not sure about the problem situation, and the problem is highly uncertain. So for such situation, your computing algorithm should tolerable. It should be a tolerable one. So the basic fundamental characteristics of soft computing is tolerance for imprecision. Even if you human being, if he could build the character of having a tolerance even with the imperfect person, then we will be treated as an ideal person. That person like that we can't see. Even in the very pressurized situation as well as the stressful situation, he is very much balancing. So that is very peculiar characteristics, and we could not able to see such characteristics even in between the human characteristics. This kind of situation is there, but for the problem solving approaches, when these kind of human like decision and natural selection has been applied, then definitely you have to face the tolerance for imprecision. Next, probabilistic nature. So what is this probabilistic nature? Whenever you want to try to solve the problem, you always not depend on these two natures, no and right and wrong, that means 0 and 1. You should always look into the possibility of between values of 0 and 1. So in that way your approaches should be probabilistic in nature. And the third one, mimic. So what is mimic? What is the inspiration? So the inspiration is the remarkable human ability, how the human is doing a wonderful remarkable procedure to solve a problem around him by means of flexibility, by means of adaptability, by means of adapting to the situations, by means of something like a flexible nature. So everything should be mimicked in this particular kind of soft computing approaches. Let me come to the core differences between hard and soft computing. So when I talk about hard computing, the hard computing works exactly on the data. It needs a data, and that data should be an exact one. That means the data should be free from errors. It should not contain any noise, and it should not contain any ambiguity. Whereas in case of soft computing, you can always work with ambiguous and noisy data. Of course, this is what we need, because when I go into depth into many of the presentations further into the lecture, you could see that all the data are not exact, all the data are not free from errors. They contain some ambiguity, and they contain some uncertainty, and they contain some vagueness. So in order to address those kind of data, definitely these kind of approaches like soft computing approaches plays a vital role. And when you come to hard computing, this hard computing is applicable only for the sequential kind of computations. Those algorithms cannot be parallelized, cannot be executed simultaneously with some other algorithms. So it lacks in it. It doesn't perform that also. But whereas in case of soft computing, you can have plenty of algorithms, and you can simultaneously execute all those algorithms like a parallel computations. As I said in the previous presentation, always this hard computing results in precise as well as accurate, that means exact results. But when you come with the soft computing, it will always go for approximation of results. So hard computing cannot handle imprecision as well as the partial truth. What is mean partial truth? The truth that lies between 0 and 1. It may not go in both the extreme, but we should consider the values between the extremes. But in case of soft computing, it can handle inexactness, uncertainty as well as the partial truth. So that you need to understand that. And in case of hard computing, the hard computing completely relies on a mathematical model, as I said earlier. Whereas in this case, human mind model, how human mind is applied over a particular problem, how that problem can be solved, very particularly real world problem. So overall picture, hard computing are not suitable for solving real world problem, whereas soft computing is more suitable for solving the real world problem. What are the constituents of soft computing? So the constituents of soft computing are neural networks, fuzzy logic and genetic algorithm. Neural network is a concept that is evolved or that gets inspired from our biological neuron, that means our human brain learning ability, right? Whereas in fuzzy logic, it has been evolved from the human brain ability of common sense as well as a reasoning ability. What about the genetic algorithm? Genetic algorithm is a soft computing technique, and it has been inspired from biological evolution process. So these are the three major constituents of soft computing, right? We will discuss in detail about one by one. Let me come to the first part, neural network. So neural network is treated as a system. It's treated as a system. That system consists of so many neurons highly interconnected with one another and looks like a human brain, and its task is to learn the situations that through data and improve its learning based on the experience, similar to what we are doing it. Sorry. So in general, this neural network mimics the human brain's ability of understanding the structure as well as recognition of patterns. So this is what neural network. Some of the applied areas are image recognition, speech recognition, predictive modeling. So and so we will discuss about so many case studies or so many applications in the days to come. But the overall picture, neural network is one of the artificial intelligence techniques that is highly inspired by the structure as well as function of the human brain. Next technique, fuzzy logic. So fuzzy logic is an approach that is meant for solving a problem where lot of uncertainties are there. It has the capability to handle the reasoning process in an approximate way rather than a fixed way. It is in general used in a control system or it is used in some sort of decision making process. Say for example, if you look at the presentation, when I say is it raining or is there any possibility for a rain today, someone may say that depending on the climatic condition there are lesser chances are there. Someone they may say that no, I don't think so, might be there, rain may comes. Someone may say that no, it is, I am very sure that today rain will come. So these are all the various statements, lesser possibility, very much possibility, little possibility. So those things has to be quantified, So those ideas are treated as fuzzy logic. Either rain or not rain. Instead of 0, that means no rain. Instead of 1, that is rain. You have to say the possible values between the 0 and 1 that gives the possibility of rain. That means certainly yes, possibly yes, cannot say, possibly no, certainly no. So that means it includes all the possible values between yes and no. So you have to see the word adjective, certainly, possibly, like those of steps between yes and no. Next, this genetic algorithm, as I said, it is inspired from biological evolution process. Very particularly, this is one of the popular optimization techniques, that is bio-inspired optimization techniques, and it is especially suitable for solving very highly important complex problems. So this is what genetic algorithm is all about, right? We will discuss these kind of algorithms very detailed in the subsequent presentations. Okay, we will come to the final part of the session. So what are these requirements for soft computing? That means if you are interested to develop any soft computing model, what you are to be ready. So you have to be ready in understanding the computational aspects of human brain. So what are the computational aspects of human brain? Its learning ability, its reasoning power, its goal seeking attitudes. By the characteristics of this 3 statement itself, what is the requirement for learning ability? Understanding the human brain's learning ability, that is neural network. Reasoning power, fuzzy logic. Goal seeking attitude, optimization, that is genetic algorithm. So these are all the 3 major requirements of soft computing. Almost in all areas you can find the soft computing applications. In the olden days, maybe in the initial period, only the engineering people started using the soft computing. Later this usage of soft computing have been widespread over variety of areas from science, arts, business, medicine and laws. So you can find innumerable number of area of applications of soft computing. And here are some list of applications of soft computing. Soft computing can be applied in agriculture, big data analytics, data mining, finance, fault diagnosis, human machine interface, intelligent agents, manufacturing systems, power electronics, power and energy, process and system, like that. You can find enormous amount of applications of soft computing. So with this, I will still say the summary what we had seen in this presentation. So where we have started, I have started this presentation with an idea of what is maybe a problem and what are the categories of problems. There are 3 categories, right? So pattern recognition, decision making and optimization. And what are the computing ways in problem solving? Hard computing and soft computing. And what are its differences? Okay, let's come to the core part of the soft computing. What are the constituents of the soft computing? Neural network, fuzzy logic and genetic algorithm. Finally, requirements of soft computing, areas of soft computing and applications of soft computing. So with this, I close this presentation. Let me see furthermore in the subsequent presentation. Thank you, one and all.